Hi, in this video, I'll be continuing doing the paper 2 for 2022 H2 Mathematics. So, for question 4, we are supposed to write this function in partial fractions. And so to do so, we need to recognize this is a quadratic below, so we'll see whether we can factorize it, and we can. And as such, it results in it being, you can do the standard method of having one fraction with one of the denominator parts and the other one with the other denominator part, which is 3r plus 2. And then you want to solve for a and b, so you need to imagine combining this into one fraction so that they are the same denominator. Then you can compare the numerator, and so a times 3r plus 2 plus b times 3r minus 1 equals to 1. So you solve for a and b, which you'll get 1/3 and minus 1/3 respectively. How to do it? Well, you just sub r as minus 2 over 3. So this part is 0. Then you calculate this. And then you solve for b. And then similarly, you make this part 0 so you can solve for a. And hence, the 1 over 9r squared plus 3r minus 2 can be written as 1 over 3 bracket 3r minus 1 minus 1 over 3 times 3r plus 2 in the denominator. So the next part, we are supposed to find an expression for the sum. So you see it ranges from m to 3m. So what we need to do is we write the sum as follows, and we use partial fractions to expand this out in the following, and you take out the 1/3 because it's constant. And then we just sub in m here, and then we get this, and then we just keep writing the terms for a lot of times until you see that when you can cancel out these terms. And so when we write our last line, we are able to cancel out this, and we're left with only two terms in the end, the first term and the last term. And as such, it will be 1 over 3m minus 1 minus 1 over 9m plus 2. So this is known as the method of difference. And once you have this, you just need to cross multiply, make it into the one denominator, and simplify. And you get 2m plus 1 over 9m plus 2 times 3m minus 1. And to find the 1 to infinity, well, you do the same thing and you just write it out, and then you see how to cancel it, and you should get 1 over 6. So now we're supposed to find the smallest value of n for which this sum from 1 to n is differing to the infinite sum, which equals to 1 over 6 by less than 0.04. So you just take 106, you minus away this term, and you take the modulus of it, or because you know this term will always be smaller than the infinite sum one, you just take 1 over 6 minus away that term, that giant term, and then you let it run, and you see that 27 is 0.00401, and then 28 is 0.00387. You can use your GC to help you do this, so you got to remember to practice using your GC, and that shows that the smallest value of n will be 28. So for the next question, question 5, we have a diagram of a circle with a line y equals to r minus h. And the shaded region between the circle and the line is rotated to form a solid. So we want to show that this spherical cap, as they call it, is this formula. So how do we do it? Well, we know that we need to integrate. It's rotated about the y-axis, so it's this way. So we need to integrate from r minus h to r of this curve. So it's respect to the y. So in that case, we need to find what is this curve in terms of y. So we see that because it's a circle, we can shift things over So it's x squared equals to r squared minus y squared, and then x will equals to plus minus this. But then we know it's on the right hand side, so it's the positive x, so it's just square root r squared minus y squared. And so when we sub it in, we just need to use the formula that the volume is pi x squared, and x squared is r squared minus y squared. Now integrating this with respect to y is simple, and so it will just be pi times pi. Then you need to evaluate the integral, which is r squared y minus y cubed over 3. And after simplification, you actually get the formula they want. So I hope this is clear. If you have any questions, you can leave it in the comments. Now we want to know ornament is made out by cutting away two cylindrical caps, one at the top, one at the bottom. And now we're supposed to find the cubic formula that is satisfied by P, and then find the value of P. So we know that the ornament will in the end be 3402 pi. So the volume of the ornament, you just need to take the sphere minus away two caps. And we already know the formula for volume of a cap. So we just need to sub in the volume of the cap with its height accordingly. And then we just need to take the volume of the total sphere, which is 4 over 3 pi r cubed, minus away the top cap volume and the bottom cap volume using this formula. And we'll have to equate it to 3402 pi. And then you simplify it out, you're able to form a cubic expression in terms of P, and use your GCE to help you solve for P. So you have three different values, but because P is this height, so what happens is that it will be P equals to 15.58, P equals to 3 and minus 2.515. You got to reject this, and because its height is bounded between 0 to 15, you also have to reject the 15.58, and as such the only possible value is P equals to 3. And continuing, now we have a different ornament and with certain criteria. So to do this question, we need to ensure that we understand the question properly and can model it. So we need to do it step by step. We have the sphere first, and then we know that the volume of the second ornament is less than the volume of the first ornament. So you know the first ornament cuts somewhere below here, so it has to cut more lah. So it has to be above the line. So then the top face of the second ornament has the same radius as the top face of this new ornament. So this is the top face. So this line, it must be the distance P. And then we know that the bottom face has the same radius as the bottom face of the previous one. So the previous one was 3 pi distance. So that means this whole thing now has to be 3 pi distance. So this means this has to be 2p. And this means that this whole thing is 15 minus 3p. But we already know p is 3. So it's actually 15 minus 3p, which is 9. So you get 6. And so now we are supposed to find the volume of this second ornament. But we don't need to know this length, because what we can instead do is use this larger cap formula over here. You minus away the smaller cap formula below, and you should get 846 pi. So I hope this is clear, and we'll move on. So for question 6, we have actually reached the probability and statistics sections for paper 2. Some might find this easier, but generally combinatorics is one of the more varied and could be harder to see how to do it. So you can pay attention when I explain it. So now two people are playing a game. So for combinatorics, they are really like it's a scenario based, and we want to find the number of ways to do something. And so you just need to understand the question and slowly use the information given. So we know that the winner of the first is the first player that throw the same number as the other player. Then Anel throws first, but we know that he has to get the same number to win. So Anel can never win first. Cannot win in his first throw. He can only win in his second throw. But Babs can win in his first throw already. So the probability that Anel wins the game must be Babs lose, Anel win, plus Babs lose, Anel win, Babs lose, Anel win. So you see, then we just continue writing it out. Is lose, 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 lose. Everyone lose first, then Anel win. So we need to always add 2 more games. And as such, we calculate that this probability is, well, for Babs to lose, he has 5/6 chance to get another number. But to win now, Anel has to get the same number as Babs, which is only 1/6 chance. And for this case, lose, lose, lose is 5/6 times 2 power 3 times 1/6. And as follows. So this is a geometric series. And so we just use the geometric series formula. So it's the first term, which is 5/36, divided by 1 minus the ratio. So the ratio is 5/6 squared. So you see, to differ by squared, squared. So then it equals to 5/11. Now, given that Babs wins the game, so now you're given a condition. So you need to think in conditional probability now. And we're supposed to find exactly the probability that she wins on her second throw. So the probability you win on the second throw given Babs wins. So this is what I like to practice, is give the question, straight away write down what you need to find. It might make it look easier because now you know what you want to find and what you're given. So instantly the formula has to be probability you win on the second throw and Babs win divided by the probability Babs win. And we already know the probability Babs win, which is 1 minus 5/11, because 5/11 is the probability Anel wins. So now Babs win on the second throw. So to win on the second throw, it means that it has to be lost, then Anel lost, then Babs win. And we can find this probability by calculating 5/6 squared times 1/6. So, and this all simplifies to 275/1296. So I hope it's clear for this video on these 3 questions. Please feel free to like, share and subscribe. And if you have any queries, I'm always in touch. So I'll catch you again. Bye.